Alright, let's look at some more inverse functions. Let's say I wanted to find a formula for the inverse of the function y equals e to the 6x minus 2. And I want to find the inverse. So start by swapping our x and y. So x equals e to the 6y minus 2. Now the way you solve an equation where the variable is in the exponent is by taking the natural log. So I'll have the natural log of x equals the natural log of e to the 6y minus 2. Now you can bring the 6y minus 2 down in front. So the natural log of x equals 6y minus 2 times the natural log of e. Well, the natural log of e is 1 because natural log means what power would you raise e to get that value in there, and the power you would raise e to get e is 1. So this is the natural log of x equals 6y minus 2. Now we need to solve for y. So natural log of x plus 2 equals 6y, or y equals the natural log of x plus 2 over 6. And that's going to be our inverse function. Now, just for fun, I want to check that and make sure that really is the inverse function. So let me go back to my original function, y equals e to the 6x minus 2. Y equals e to the 6x minus 2. If it is the inverse, f of f inverse of x should equal x. So I'm saying y is, or f of x is e to the 6x minus 2, and I'm claiming that f inverse of x is natural log of x plus 2 over 6. So what is f of f inverse of x? So that means I want to find f of the natural log of x plus 2 over 6. So that means I want to replace x in f with this value right here. So this equals, I'm going to take f, which is right here, and replace x with natural log x plus 2 over 6. This is e to the 6, and instead of x, I'll have natural log x plus 2 over 6. That's over 6 minus 2. Alright, so now these 6's cancel, and I get e to the natural log of x plus 2 minus 2, which is e to the natural log of x, which is just x, so they are inverse functions. Okay, now what if my original function that I want to find the inverse of has a log in it? So let's say f of x equals 6 times the natural log of 2x plus 4. And I want to find f inverse of x. So I start by saying y equals 6 natural log 2x plus 4. Swap the x and the y. X equals 6 natural log 2y plus 4. In order to solve this for y, I have to get the log by itself. I can't have that 6 in there, so I'll divide by 6. So I get x over 6 equals the natural log of 2y plus 4. Now to get rid of natural log, I'll use its inverse function, which is e. So I make both sides powers of e. So on the left-hand side, I have e to the x over 6. On the right-hand side, the e and natural log cancel, and I get 2y plus 4. I'm solving for y, so subtract 4 from both sides. E to the x over 6 minus 4 equals 2y, or y equals e to the x over 6 minus, that's not in the exponent, is it? No, it's not. Minus 4 all over 2. So that is my inverse function. And like before, I just want to check that. So I'm going to plug that in. And I should get x, because the f of f inverse should be x. So f of x was 6 natural log 2x plus 4. Now I want to find f of f inverse. So I replace x with f inverse of x. So natural log 2 times, and then instead of x, I put e to the x over 6 minus 4 over 2 plus 4. So that equals 6 times the natural log. These 2's cancel, and I get e to the x plus 4 or minus 4 I can't get rid of that somehow. Minus 4 plus 4, or 6 natural log e to the x, which is 6x, which is not what I was supposed to have. So let's see, where did I lose my 6? X over 6. This was supposed to be x over 6 right here. This was supposed to be x over 6. So this is a natural log, 6 natural log e to the x over 6. Remember, a number out in front can come up on top. So this is e to the x over 6 times 6, which is a natural log of e to the x, and the natural log of e to the x is x. So these are, in fact, inverse functions of each other. Okay, let's find the exact value of some expressions. Let's say I had the log base 3 of 1 over 27. I can write this as the log base 3 of 1 over 3 to the third, or the log base 3 of 3 to the negative 3. And then that means that this equals negative 3, because what the log is what power would you raise this number to get this number? And the answer is negative 3. So looking at this problem, what power would you raise 3 to get 1 over 27? It'd be negative 3. What if I had the log base 81 of 1/3? So what power would I raise 81 to get 1/3? Well, I know that 81 is 9 times 9, which is 3 squared times 3 squared, which is 3 to the 4th. So I know 81 is 3 to the 4th. That means that 81 to the 1/4 is 3. But I don't need 3, I need 1/3. So 81 to the negative 1/4 is 1 over 3, and that's what I need. So my answer here would be negative 1/4. Okay, what if I had e to the 2 natural log of 4? Well, I know that e to the log of x just equals x. But this is not quite e to the log of x, so I need to bring this 2 inside as an exponent. So this is e to the log of 4 squared, or e to the log of 16, and now e and log cancel out, and I just get 16 would be my answer. What if I had e to the minus 2 natural log of 6? Again, if I just had e to the natural log of 6, I would say it's 6, but I've got to get rid of that 2 first. So that's e to the natural log of 6 to the negative 2. Well, now the e and natural log cancel out. I get 6 to the negative 2, which is 1 over 6 squared, which is 1 over 36, and that is the answer that I need. Okay, now one last one. What if I had the natural log of e to the natural log of e to the x squared? Well, starting on the inside, the natural log of e to the x squared, natural log and e are inverse functions, so that just gives me x squared. So this is the natural log of e to the x squared. Now, natural log and e are inverse functions, so this just gives me x squared.